Hi algebra students, welcome back for part 2 in our 3-part review series. Today's review is going to be brought to you by my Aunt Sally. Wondering if you've got an Aunt Sally too. I really do have an Aunt Sally. Alright, so we all know this. Please excuse my dear Aunt Sally, okay? P stands for parentheses and grouping. E for exponents. M, multiply. D, divide. A, add. S, subtract. Now, some of you may also have heard, instead of PEMDAS, about something that we call PERMDAS. Notice our new letter in there is an R. And think about what you learned about in our review before this. Radicals. Yep, because exponents and radicals are inverses of each other, just like multiplication and division, addition and subtraction. So it's nice to put that in there. Now, we can take all of our radicals and write them as exponents. We will get there probably third quarter, and that's why it's typically left out. But then some people like to put it in. Some people, namely Mr. Martin. Okay, so we simplify our algebraic expressions using this mnemonic. Please excuse my dear Aunt Sally. We do the parentheses first, exponents second, so on and so forth. So let's review some of these. So I'm not simply going to give you an expression. I am going to have you first substitute values in and then simplify. So when you hear substitute, that means every place you see a letter X, you put in a 5. Every place you see a letter Y, you put a 2. I recommend that you put parentheses around these things because otherwise you could end up with a mistake right here in the middle and you put in that 5 and the 2 and with no parentheses that looks like 52. But if we put parentheses around everything that we substitute in, we can see more clearly that we actually have to multiply those two things and it really has a value of 10. So let's go ahead and start with example A. So 2x, every time I see an x, I put a 5 in parentheses, minus xy, 5 times 2, plus 4y, 4 times 2. According to my order of operations, I have to do parentheses first. I see parentheses here, but right now they mean multiplication. Then exponents, I don't have any exponents, and now multiplication. So 2 times 5 is 10, minus 5 times 2, which is 10, plus 8. Now that I have addition and subtraction, this is where most of the mistakes actually take place, is right here, okay? When we only see addition and subtraction, okay, because they are inverses, we need to move from left to right. So maybe make a note to yourself somewhere, okay? When you just see addition and subtraction, go left to right. Oh, I'm sorry, I can't see what I'm writing. Okay. Or sometimes what I do on my notes when I write down PERMDAS, I go ahead and I take a new color and I put over the AS an arrow, MD, because this is true every time you have these inverse operations. If all you're left with is multiplication and division, you move left to right. If all you have left is addition and subtraction, you go left to right. So if we move from left to right here, okay, first I'm going to do 10 minus 10, which is 0. And 0 plus 8 is 8. And that's our final solution. Let's go ahead to the second example. Again, we're first going to substitute, and then we will simplify. I see a q squared there. Every time I see a q, I'm going to put a 7 in its place, plus 4q, which is 7, r is 3, minus r squared. Parentheses. All my parentheses here mean multiplication. Exponents. I see a couple exponents. 7 squared is 49. 3 squared is 9. No radicals. Now I've got some multiplication to take care of in the middle here. 49 plus 4 times 7 is 28. I'm going to grab my calculator. 28 times 3 is 84. Minus 9. All right, left to right. I know I'm going to have a negative answer here. 49. Oh, I'm sorry. I thought I said minus 84. I'm going to have a positive answer. 49 plus 84. We're at 133. Minus 9. 124. Okay. One more piece here with simplifying expressions. Okay. And that's in relation to combining like terms. Okay. When we have an algebraic expression like this, where we've got variables in it, we combine the like terms. What like terms are is they have the same variables and the same exponents. So same variables means same letters and same exponents. The parts of the expression that do not have variables are called constants, and then we combine our constant terms. Okay, let's simplify this first expression that we see at letter A. First thing I'm going to do is highlight my like terms. So same letter with same exponent. Here I see an x squared. I see an x next to it. That is not a like term because it doesn't have the squared part. So I see another 4x squared down, or another x squared term down at the right. My other two terms that are not highlighted are 2x and 3y. They have different letters. They are not like terms. So let's go ahead and combine the two that are alike. It says 3x squared plus 4x squared for a 7x squared. Add your coefficients. The things that cannot be combined, you simply just write down. Most mathematicians go from increasing to decreasing order with their exponents and then alphabetical order with their variables. Okay? But if you were to write this in any order, you would be fine as long as that 3 has a negative or a minus sign in front. All right, one more to practice. Let's look for our like terms. Oh, what's different about this one though? Yeah, there's this J, and then we've got parentheses with all these things inside. Before we can simplify and combine like terms, we need to distribute that J to the terms inside. Okay, so, we've got 6jk squared plus 7jk plus, now I'm going to just write down what was after the parentheses. Now I'll look for my like terms. So I see a jk squared here and a jk squared there. And then if I look at the other parts of my expression, I've got a jk and a jk. So I'm going to combine the yellow terms, and then I'm going to combine the blue terms. So the yellow terms, it says 6jk squared plus 9jk squared for a total of 15jk squareds. Then I have a 7jk minus 7jk. So 7 minus 7 is 0. I don't have to write plus or minus 0 in my expression. So this simplifies down to 15jk squared. All right, so here's your summary challenge. Explain how adding like terms involves the distributive property. So I don't want you to think of what you just saw, where you had to use the distributive property before you could combine like terms, okay? But think about if you have terms like this, 3x squared plus 4x squared, okay? How does the distributive property come into play when you're doing this? It happens. It's there. And then go ahead and complete these 8 problems, and then go on to part 3 in our review.